Hey there, welcome back to this video on simplifying trigonometric expressions. In this video, we're specifically going to focus on factoring with trig. Okay, so let's go ahead and look at the first example here. We have secant squared theta minus 1. Okay, and kind of what you need to get used to is when you see a secant squared, just know that this is secant theta quantity squared minus 1. And really what you should see here is difference of two squares. I have secant theta that's squared, and I have 1 that's squared. So if you remember back to your factoring days, I can go ahead and split each perfect square and just add a addition and a subtraction in between. And we're done. That's it. Can you believe that? That was pretty simple. Okay. Here's our next one. In this one, we're asked to factor the expression. And again, I have 4 tan squared theta. So that's just tangent theta squared. Okay, and what I want you to think about is what if I had asked you to go ahead and factor 4x squared plus x minus 3. Okay, and you would tell me that, hey, that is x plus 1 and 4x minus 3. Okay, so I can go ahead and check this, right? And I get 4x squared and negative 3x with a positive 4x minus 3. Yes, okay. So think about it like that. So I have 4 tan squared theta. So this is, and if I follow that, just that the same idea, right? We have tan theta plus 1 times 4 times tan theta, okay, minus 3. And if you don't believe me, so that's your answer, believe it or not. But if you don't believe me, you can always go ahead and check. So I'm going to check. So this gives me 4 tan theta squared, okay, which is 4 tan squared theta, okay, minus 3 tan theta, okay, plus, actually I'm going to do down here, plus 4 tan theta, okay, minus 3. Right, so all I did was FOIL, right? This times this, this times this, this times this, this times this, that. Okay, and it gave us it. All right. Okay, here is a practice example. Please go ahead, pause the video, and try this one. All right, so I hope you saw difference of squares. Here is the solution. Okay, 1 minus cosine theta, 1 plus cosine theta. All right, here is the next example. Please go ahead and factor this one. Okay, hopefully you saw 2x squared minus 7x squared plus 6, right? So you can factor it the same kind of way that you would with a regular quadratic trinomial. All right? All right, and then last but not least, here is another one. Okay, hopefully you pause this and try this. This one's really good. This one involves a GCF, right? They both have a factor of a 3 and a sine theta, so you can factor that out, and hey, there you go. So that's factoring, right? And that's pretty straightforward. All right, now we're going to go ahead and factor, but it's not going to be straightforward. So I could go ahead and factor the other ones like a quadratic trinomial because my term that I was using was consistent. But if you go ahead and you look, my leading term that's squared is cosecant squared, and my middle term is cotangent. Well, they're not the same, so I can't just treat this like a quadratic, right? They have to be the same. So what can I do? Well, you can go ahead and you can utilize your Pythagorean identities. Okay, and your Pythagorean identities, remember, come from sine squared plus cosine squared equal to 1. Okay, and what we're going to do is I'm going to substitute out cosecant squared of x. Okay, so how does the Pythagorean identities tie in? Well, you don't see it, but can't I go ahead and get cosecant squared x by dividing all of this by sine, right? Sine squared, divide by sine squared, divide by sine squared. Okay, and then you'll notice here, right, 1 over sine squared is, lo and behold, your cosecant squared x. Okay, so we'll go ahead and simplify. This is 1 plus cotangent squared of x. Okay, and what I hope you see that happened, that's really sweet, right? If I just go ahead and substitute. Okay, so now this is 1 plus cotan squared x minus cotan x minus 3. So after I clean this up, what you should see now is that my two trig functions match. Minus 2. And hey, now I can treat it like a quadratic trinomial structure, right? This is the same thing as x squared minus x minus 2, right? So we can go ahead and factor it as such. So that would be x plus 1, x minus, see, I switched it in my head. Not x, it's cotangent. Cotangent of x plus 1, cotangent of x minus 2. And you're done. There it is. That's simple, right? Okay. All right, here is a practice one. Please go ahead, pause the video. I want you to try this one. All right, so hopefully you have paused the video. Here is the solution. And you do the same thing. You just substitute in that trigonometric identity. Secant squared theta is equal to 1 plus tan squared theta. When you do that, now your trigonometric expression has the same trig function. Okay, so here is the last type of example that I'm going to show you, and it says perform the addition and simplify. Okay, and what I hope you see in this example is I have two fractions that I can't add because I don't have a common denominator. Okay, and so what we're going to go ahead and do is kind of perform some math magic. Okay, and what we're going to do is multiply this side by the conjugate. So I have 1 minus cosine theta over here, 1 minus cosine theta, right? So I'm multiplying that expression by 1, so I'm not changing it. And then over here on this side, I'm going to go ahead and multiply by sine theta over sine theta. Okay, so why am I doing this? Well, I'm going to go ahead and show you why I'm doing this here in a second. So what we get on this side is sine theta, okay, minus sine theta cosine theta, all over, okay, 1 minus cosine, well, I'm going to go ahead and just distribute first. So 1 plus cosine theta minus cosine theta, okay, minus cosine squared theta, plus, over here, we get sine theta, cosine theta, all over sine squared theta. Okay, so again, all I did was just distribute. Now we'll go ahead and kind of simplify some stuff. So again, sine theta minus sine theta cosine theta. And in the denominator, right, my middle two terms here, they cancel. So we get 1 minus cosine squared theta, okay, plus sine theta cosine theta over sine squared theta. And now what I hope you see is a Pythagorean identity. 1 minus cosine squared theta, and we've done this multiple times in this lesson. We've gone ahead and substituted, right? We know that sine squared theta is equal to 1 minus cosine squared theta. So all we're going to do, right, is take this and we're going to substitute it out for sine squared theta. So this becomes sine theta. Man, this numerator is lengthy. So over sine squared theta, okay, plus sine theta cosine theta over sine squared theta. Okay, and what I hope you see is that they have the same denominator. So I can go ahead and I can rewrite this. So this now becomes sine theta minus sine theta cosine theta plus sine theta cosine theta, okay, all over sine squared theta. All right, so what happens? Well, notice that these two terms are opposites, okay, so they cancel, and we now have sine theta over sine squared theta, okay, which after this cancels, we get 1 over sine theta, which is equal to cosecant theta. What? Are you kidding me? All that for just cosecant theta? Yeah, that's all it was. It just simplified it, broke down. Okay? So, some of you are probably bamboozled still, like way up here. Like, why did I go ahead and multiply by the conjugate? One, because I kind of had an idea of like where we were going. But anytime, here's like a hint, anytime you see a 1 plus cosine theta, right, and you need to kind of change the denominator, always think conjugate, right? And we've done this before. The conjugate is the same two terms, it's just the opposite sign in between the two terms, right? So this can kind of create a different type of denominator, and it did, right? It gave us a Pythagorean identity, which led us to go ahead and add those, okay? All right, so here is a practice problem. Very, very similar, okay? So you should see that structure, and it's not as complicated. But go ahead, try this one. All right, hopefully you have paused the video and tried it. Here is the solution. Okay, so you multiply by the conjugate, which is 1 minus sine theta, and on the right side, 1 plus sine theta. Okay, giving us 1 minus sine squared theta, which is cosine squared theta. So we get 2 over cosine squared theta. Well, at this point, right, I can use the reciprocal identity, okay, and that is just 1 over cosine theta is secant theta. Okay, all right, that does it for this video. I hope you enjoyed factoring and simplifying some trig expressions. All right, catch you next time.